A couple of concept checks. So these are just questions I'm going to ask you, sort of a little tiny quiz on the material we just covered. So let's imagine you are very wealthy and you would buy luxury clothing no matter what the price is, right? So you're highly inelastic in your response. The price of luxury clothing goes up. What happens to your consumer surplus? Does it go up, down, stay the same? You're down. Right, it's going to go down, right? Even though you're super wealthy, even though you're still going to buy the same thing before and after, even though you're not really going to be like hurt that much by the increase in the price, you can afford it, your consumer surplus is still going down, right? It's still a worse deal for you, right? Regardless of the fact that you might, not get that affected by it. All right, next question. Government wants to reduce smoking, so put a price minimum on it. Basically, they're saying, hey, if you want to buy a pack of cigarettes, fine, but each pack's going to be like $30, right? That's the law here. So compare two possible scenarios. One, smoking demand is very elastic, or B, smoking demand is very inelastic. The first question is the actual quantity of smoking, are people going to smoke less in scenario A or scenario B? What do you think? Okay. If you're A, who thinks it's A? All right, who thinks it's B? All right, yeah, so, so elasticity is all about quantity responses. If you want the quantity to drop a whole lot in response to a price change, you want a more elastic demand. So if smoking is very elastic, we would expect that quantity would drop by more in the elastic scenario as the price goes up. All right, next question. Is consumer surplus going to be affected more in situation A or situation B? That's a little tougher, right? But think about that for a second. Raise your hand if you think it's going to be if consumer surplus is going to drop more in situation A. All right, how about situation B? All right, so it's going to turn out to be situation B. That is a hard one, right? So I'll show you why. Inelastic demand, elastic demand, and we're going to do the same price increase. So we get a price increase. Basically, what's going to happen is that in the inelastic scenario, you're going to keep buying all those now super expensive cigarettes, right? Whereas in the more elastic scenario, you're going to get a little bit of relief on the price increase because you're just going to buy fewer cigarettes, right? If you were buying 2 packs a week before, and your price just doubled, right? And now you buy 1 pack a week. Well, you only got your price increase on 1 pack a week, right? So you're not going to be affected quite as much. You're going to go do something else with the money at time. Whereas if you keep buying 2 packs a week, you're paying that whole extra money, right? So that's really going to be a drop in your consumer surplus. So quantity is going to be affected more in the elastic scenario. Consumer surplus is going to be affected more in the inelastic scenario. Any questions about that one? Next, if we can describe the marginal benefit as this equation right here, marginal benefit is 55 minus 5Q. The good is sold at the price of 10. How many units will you choose to buy? All right, let's go over this. So, first thing we got to know, right? What's the rule that we're going to use to figure out the answer to this? The golden rule, of course, is marginal benefit equals marginal cost. What is marginal benefit? Well, there it is. It's 55 minus 5Q. What is marginal cost? Well, every time we buy another unit of whatever this good is, we have to pay the price, which is 10. So that's going to be our marginal cost. So we just need to solve this. So we get 45 equals 5Q. Divide both sides by 5. We get 9 equals Q. So we will maximize our economic surplus at a quantity of 9. Our last one. If the total cost, this is a hard one. If the total cost of producing the good is 10Q, and the demand curve is price equal to 100 minus 10Q, have we achieved efficiency at a quantity of 5? You might have to think about how you're going to do that one for a second, but think about it. All right, let's come together and see what we got. How many do you think that we do achieve efficiency at a quantity of 5? How many do you think that we don't? All right, this one was tricky, admittedly. So we know that we're going to want to set marginal benefit equal to marginal cost. Great. Okay. Given what we know about the demand curve, what is our marginal benefit going to be? What's that? Where can I find it on the slide? Society's point of view, yeah. So yeah, it's going to basically just be whatever P is on the demand curve, right? Because on the demand curve, whatever price we're willing to pay, that is our marginal benefit, right? Because that comes from our consumer side, marginal benefit equals marginal cost. So for the consumer, marginal benefit, we're going to set that equal to price, right? So we can fill in 100 minus 10 Q, right? And if we're interested specifically in a quantity of 5, we can even plug in the quantity of 5. So we have 100 minus 10 times 5, or 50. Okay, great. Now we want that to be equal to marginal cost. So where on this slide can I find the marginal cost? This is the tricky part. I think this is, for everybody who said yes, this is the part where you got tripped up. Because the answer is no. So here are our total costs. Remember, total and marginal costs are different, right? So the total cost of producing that many units is 10Q, right? But the marginal cost is how much additional cost we face every time we make one more unit. So every time we make one more unit, how much do our costs go up by? Is 10, just the 10, right? Because let's say, for example, we have a quantity of 4. Our costs are 10 times 4, or 40. If we increase that to a cost of 5, then our costs are 10 times 5, or 50. Every time we make one more unit, our total costs go up by 10, which is what the marginal cost is, right? So the marginal cost is just going to be 10, no matter what quantity we're producing. 50 is not equal to 10, so we are not achieving efficiency at a quantity of 5. If we wanted to know what quantity we would achieve efficiency at, right, we would say 100 minus 10Q is 10, right? So here's our marginal benefit from society's point of view, whatever the consumer is getting out of the good. Here's the marginal cost from society's point of view, it's whatever the resources the producer has to put into the good. And we can solve this. So we get 90 equals 10Q, and Q is 9. That would be the efficient quantity.